Lesson 11.4 is all about geometric series. Now, just like an arithmetic sequence, say 1, 3, 5, 7, continuing on, would have a arithmetic series by adding them together. So we take our sequence and we add it. That's how we make it a series. So our geometric sequence, say 1 times 3 is 3, times 3 is 9, times 3 is 27. So in this case, our common difference was 2. In this case, our common ratio is 3. We can make it a geometric series instead of sequence by adding these ones up, the same way that we would add up an arithmetic sequence to make it an arithmetic series. So let's see how these work. Anytime we are given a geometric sequence or asked to find a sum of a geometric series, we want to look at one of these formulas here. The first one in red, this one just kind of states the basic that our sum, S sub n, equals a sub 1, our first term, minus our first term times our common ratio to the power of n. All of that is divided by 1 over r. Now that's not too terribly difficult, but we can factor out this a sub 1 and make it look like this green one. So we'd have the a sub 1 on the outside times 1 minus r to the n all over the 1 minus r. So let's not look at the red one so much. Let's focus on only using that green one. That one will be a lot easier for us to use. So using that green one, let's see how one of these examples actually looks. If we want to find S sub n when our a sub 1 is 2, our r equals 2, and our n is 15. Then we just plug everything right into our formula here. Our S sub n equals a sub 1, which is 2, times the amount 1 minus r, which is 2, to the power of n, which is 15, and then all of that divided by 1 minus r, which is 2. So that's how we first initially set it up. Now all we have to do is just solve right through. So we would say it would be 2 times the amount 1 minus 2 to the 15th is 32768. Pretty large number. 1 minus 2 is negative 1. Again, now we just keep solving right through. 2 times 1 minus 32,768 becomes negative 32767, still over negative 1. I'm going to come down here now and say 2 times that amount becomes negative 65,534, still all over negative 1. Negative over a negative, those cross out, and so we get then that our S sub n equals 65,534. And if we want to be even more exact, we'd say it's not S sub n, we know specifically that it's S sub 15. It's the sum of the first 15 terms of that geometric series. Awesome, so let's move on from there. Our sigma notation that we learned from the arithmetic sequences, that holds up as well. We can still do things in a sigma notation. So let's see exactly how those work out. If we are given something in the form of our sigma notation, where y is on top, k equals x is on bottom, and then we have a formula or an equation a times b to the k minus 1, well then we need to go back to our S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r, but we don't necessarily know what a sub 1, r, and n are. But we can find those out just as easy. N is our y minus x plus 1, and that's found y is on top. X is this value right here. Our a sub 1 is just this a value right here. And our r value is the b value, this one that's being raised to the power. So in this case, we would say that our n equals 12 minus 1 plus 1. So it's just going to be 12 is our n. Our a sub 1 value is just going to be that 3, that one in front. And our r is going to be the one raised to the power, so it's going to be 2. So now we know all the values we need to plug into our original formula. So when we do that, we have s sub n equals a sub 1, which is 3, times the amount 1 minus r, which is 2, to the power of n, which is 12, all over 1 minus r, which we said was 2. So again, we have everything set up. All we have to do is solve for the individual pieces. So we'd have 3 times the amount 1 minus 2 to the 12th is actually 4,096. All over 1 minus 2 is negative 1. Come down here then. So we'd have 3 times the amount 1 minus that gives us a negative 4,095. Again, still all over negative 1. 3 times negative 4,095 comes out to negative 12,285, all over negative 1. Those cancel out, and anything over 1 is just itself, so our answer is 12,285 equals, we can either say s sub n, or we know specifically that there are 12 of them, so it's the same as s of 12. So the sum of the first 12 terms is 12,285. Now, if we want to determine the full sum, but we're not given how many numbers there are, but we know where we start, our a sub 1, and we know where we end, and we are given our r, we can still figure it all out. We don't necessarily need to know how many numbers there are, we just need to know which each of those are. So when we are given our a sub 1, our a sub n, and our r, this is the formula we use. Our a sub 1 still comes out in front, a sub n comes here in front of our r, and we're still over 1 minus r. So this is another formula we can use to solve this out. So again, in this example, all we have to do is plug everything in. So our a sub 1 is 7,776. We'd say minus our a sub n, which is 6, times our r, which is negative 1 over 6, all over 1 minus r, which again, r is negative 1 over 6. Okay, now all we have to do is continue to solve through. So we'd say 7,776 minus, well, 6 times negative 1/6 comes out to negative 1. And 1 minus negative 1/6 is going to come out to 7/6, or 1 1/6. Continuing to solve here. 7,776 minus a negative 1 is the same as adding 1. So it becomes 7,777 over 7 divided by 6. And anytime we have a whole number divided by a fraction, remember that's the same as saying if we change our whole number into a fraction and we multiply by the reciprocal. Dividing by fractions is the same as multiplying by the reciprocal. So we would say times 6/7. Well, in this case, our 7's cancel out, leaving 1 here and leaving 1,111 here. If we multiply straight across the bottom, our 1's, anything over 1 is just itself, so we don't have to worry about that. So it's just 1,111 times 6, which then we would say the sum, and we don't know the end, so we don't know how many terms it is, but we know that the full sum then is 1,111 times 6, or 6,666. So that is our full sum. Now if we're looking for specific terms, so if we know that the total sum in this case is 765, and that our R, common ratio, is 2, and we want to just find our first term. Well, in this case, we just set up our formula, S sub n equals a sub 1 times 1 minus r to the n, all over 1 minus r, and plug in the things that we do know. So in this case, we know our S sub n, which is actually S sub 8, equals, we don't know a sub 1, we know 1 minus r, which is 2 to the n, and n is this number 8 here, all over 1 minus r, which remember r is 2. So we know most of it. We also know that S sub 8 is this 765. So now we have a full equation and only one unknown, r a sub 1, which is what we were looking for. So we just continue to solve through here. We say 765 equals a sub 1 times 1 minus 2 to the 8, which is 256, all over 1 minus 2 is negative 1. I'm going to do two steps here at the same time. I'm going to multiply both sides by negative 1, times negative 1, and I'm going to do 1 minus 256. So we'd say then negative 765 equals a sub 1 times 1 minus 256 is negative 255. Now I will just divide negative 255 out of both sides. This should be a negative. And so we would say then that a sub 1 equals 3. That's simple. So by this point, we should have 3 new formulas for your reference sheet. You want to make sure you know these. This was our main one. This was the factored version where we took a sub 1 out. So the sum of a geometric series equals a sub 1 times the amount 1 minus r to the n all over 1 minus r. That's kind of the big main original one. In this case, we're just saying that the sum of the geometric series is our first term minus our last term times the common ratio, and this is all one term here. So it's this number minus this number. You can't do them separately. And all over the 1 minus r still. Get rid of some of those. And in sigma notation, if we are given in this form, or at least something similar, again, it won't always say k right here. It might be n or something else. This isn't necessarily always y. This isn't always x. But if we have something that looks like it's in this form, we would say our n value is that top number minus the bottom number plus 1. Our a sub 1 value is this guy right here, that a value, and our r is b. It's this number that's being taken to a power. Once we know these values, we plug them back into our original formula, and that's how we find the sum of our geometric series. So with that, stay golden.